Uh, Thank you, everyone. This is Arun Kumar from Space Application Center. Today, I'm going to present a brief paper. We can say it's a presentation on intercomparison of GHRSST products of different resolution and data sets, which is a small case study which we have conducted in the North Indian Ocean. The other contributors of this paper are Mr. Anshul Agarwal, Rishi, Dr. Jishad Nijar sir, Pradeep sir, and Rashmi madam. This is a brief outline of the presentation, which contains introduction, data sources, validation methodology, comparative analysis of daily, seasonal, and full year, key findings, and concluding with the conclusion session. And for this forum, I need not again introduce what is GHRSST. However, I need to stress about the importance of SST data and its accuracy, because it is a paramount parameter in the as far as the physical, biological, and chemical oceanography in the point of view for conducting different fields and applications in the I've listed here, not limited to this climate research, especially in climate modeling and climate change studies for the long-term analysis, weather forecasting, especially the tropical cyclone prediction. It is and intensification. SST plays a very major role. In the oceanography related aspects, SST is a prime parameter which can help in identifying warm and cold core eddies, upwelling and downwelling. And especially in the morning, INCOIS director has mentioned about this PFZ activities, and where the SST is one of the major parameter. Environmental monitoring, pollution, and in the morning session, Dr. Nandini from SAC has presented related to the coral bleaching and all. And the last is tourism and recreation. So coming to the data sources, since this is a pilot study, it's a small study which we have which we have conducted for 1 year, 2021, for the region consisting of Northern Indian Ocean. The latitude and longitudes are present here, and we analyzed 5 GHRSST products from different Met agencies. The list is here: Canadian Meteorological Center, CMC, DMI, Danish Meteorological Institute, JPL Mur data, and RS systems, REMSS, and UK Met Office data. And you can see that they are all of different resolutions as well. And the right side, we have put a table which briefly tells the what kind of data, what kind of satellite data is going to to bring the product. For example, on the right hand side, the platform sensors used, we have mentioned here. And out of all this GHRSST data, UK Met Office is using large number of data sets. More than 25 sets of data sets are going into that, and the methods they used to produce this are also mentioned here. Mostly all the centers are using optimal interpolation as a method. And for this purpose, we have used ICOM data, which is an in-situ quality monitoring data, which contains the data from several platforms, including ships, drifting buoys, mood buoys, as well as Argo floats. We have considered all the data in this work. The validation methods is like this. We acquired the in-situ data, we downloaded and we processed the data, and we maintained that only the accurate quality data should be used, so that we have used flag is equal to 5, so that the poor quality data is discarded from the analysis. And we have different resolution data sets. So considering this native resolution of GHRSST, we have averaged our in-situ data into daily average data and prepared collocated data sets for comparison. And in the next step, we have comparatively analyzed analyzed data set at the native resolution, as well as regraded products of 10 kilometers. And the seasonal mean and standard deviation of GHRSST from different products have been computed, and daily statistics have been presented. And we can see the right bottom how we have taken the daily mean, so that you can see the green portion indicates the different data sets coming in one particular grid value, so that we'll take the mean and we used for the comparison. So this is a general picture how it looks, the temperature gradients or thermal gradients of different products. Obviously, 1 kilometer data set will have a very clear structure of gradients as compared to the 10 kilometer gradients. But we need to see which one is accurate enough for a broad applications point of view. So this is the histogram. The histogram is not showing any specific deviation or in the mean as well as in the range. So in the native resolution as well as in the 10 kilometers resolution products. So this is the actually what we wanted to show here is at a native resolution CMC is giving around RMS value of 0.25 degrees centigrade. At the same time, UCOM at office SST product also is giving the almost same RMS value with the almost near close bias as compared to other products, JPL, DMI, and RMS. REMSS. DMI is pretty giving larger RMS error around 0.45 degrees centigrade. At 10 kilometer resolution means we have regraded the data and we again rechecked the data, and we have found that JPL is going a little bit worse as compared to the earlier data set. It was earlier 0.299. Now it is become 0.395, and other data sets are not having much deviations from the native resolutions. And this is actually the interesting result which we have done for a daily basis. For each day, the data sets available from the institute data has been compared with the respective GHRSST products and computed these stats. So you can see RMS value, how it is daily ranging from January to December. And we can see out of all the products, DMI is showing larger deviations of around more than 1 degree centigrade during the May-June months. And coming to the correlation coefficient, it's very interesting to us also, because January to March, pretty good result. We can see around more than 0.9 correlation coefficient is seen in all the products. But from March onwards, up to the May end, up to June, we have seen a gradual decrease in the correlation coefficient in all the data sets, with DMI is obviously showing the more deviation. So this is the bigger peak, and the secondary peak is observed during October-November months. As we all know, in Indian Ocean, North Indian Ocean, this is linked with the transition phase. The April-May is pre-monsoon, and October-November are post-monsoon seasons. We have to see why this is coming exactly. This could be due to the transition phase where the winds change from one direction to another direction, and the mixing dynamics also changes drastically during this period. So we have taken three points which are falling in different categories from, for example, in January, where the correlation coefficient is high, and during the around May, where the correlation coefficient is June, is relatively poor, and in secondary peak and during November also. And respective day, this is the respective day, and we have overlaid the whatever available data on these maps. These are individual dates. You can see almost all the products are showing very good matching. But if you go with the May month, on 25th of May, where we have seen very poor correlation, especially in DMI, we can see a very relatively warmer Bay of Bengal as compared to the other regions. So this has to be studied further why it is showing like this, and there are very lot of mismatches in the data also. You can see the background color is different, and the point which indicates the institute data, the color is different. Color means indicating the value, exact value of that point at that place. So this could be due to transition phase, mixed layer changes, and due to cloud effects also, because during that time clouds also will be there. There are lot of data gaps in the satellite data also. So this could be one of the reasons which we are thinking about. And in on November 15th, it is okay, but at some places there are not they are not going into the not properly matching. You can see in the mid Arabian Sea, the points are not at all matching not at all matching. So we have taken the southwest monsoon, we have taken the mean. The top slides are the mean of southwest monsoon season, and the bottom slides are the standard deviation, which we know standard deviation gives the variability of the particular phenomena. And you can see the west coast of Arabian Sea is showing the strong standard deviation signals in all the data set during the time, and with a relatively cooler water surface in around this region. During northeast monsoon, we expect the winds coming from the northeast also. So we can see in the northern Bay of Bengal, the winds are relatively, the sea surface is relatively cooler, and the dynamics, the variability is also relatively stronger here, as well as in this region also, northeast. There is a dominance of northeasterly winds. During the pre-monsoon season, we can see a significant variability of more than 2 degrees standard deviation in all the data sets, where especially in the Gulf of Oman and Persian Gulf waters, and cool surfaces are observed in this region. During post-monsoon season, and then North Indian Ocean has temperatures more than 26 degrees. This could be one of the reasons where we get the probability of cyclones will be more during post-monsoon season, especially in the Bay of Bengal. And this is the full year study, which is a combination of all the seasons, and we can see the large variability in entire west coast of Arabian Sea, and as well as the northern Bay of Bengal. All the GHRSST data sets are showing the same variability here. So there is no much difference as compared to the when we talk about the validation. We are seeing the little deviations, but if as a picture, as a map, we are not able to see any drastic difference within this. So these are the key findings which already I discussed. JPL SST data is, since it is a very relatively high resolution data, it is very capable to resolve small scale features. This could be a potential database for PFZ identification. However, our comparative analysis for 1 year has shown that the correlation coefficient is relatively poorer as compared to the other 4 data sets. When it is interpolated to 10 kilometer resolution also, there are no major changes observed. So datasets from CMC and UK Met Office are giving better comparison with the institute data, around 0.25 degrees centigrade RMS error, and DMI is showing relatively poorer results. But this is not a conclusion, but for a further study, we need to analyze more data with more independent datasets. As we all know, this ICOM data is already used in producing this GHRSST data, but we wanted to see the interpolation methods, the methods used to generate these products, what is the impact of that, and even then also we have seen the certain deviations from the actual value. So all these data showed significantly poor statistics during pre-monsoon and post-monsoon. So that's from my side. Thank you very much for giving me this opportunity. Sincerely thank Director Sir and everyone who has given me this opportunity.